Lesson 8 is quadratic equations in context. So we're just going to work on writing and solving quadratic equations and inequalities as well. Remember, inequalities are just like something with like the less than or like the greater than or equal to symbol, but they're structured pretty much the same way as a quadratic equation would be. It's just the equal sign that's different. It's an inequality symbol. Okay, so the first section is 8.1 and 8.2 together. So in the workbooks, like 8.1 takes a set of problems and you're just setting up the equation, but then 8.2 takes the same exact problems and just asks you to solve them. So we're just going to do it all together instead. So example 1, Rosario wants to install a sidewalk around her garden. The garden is 6 feet by 12 feet, and she wants the width of the sidewalk to be the same on all 4 sides of the garden. The combined area of the garden and the sidewalk needs to be 187 square feet to fit in her yard. Write an equation that represents the combined area of the garden and the sidewalk, and then find the width of the garden. Or sorry, width of the sidewalk. Okay, so they give us a nice picture, which is cool. In order to figure out not like our like exact width, but like an expression that we could use to represent width, we can use this picture. So if I want to find the width of the garden, including the sidewalk, so the garden itself is 12, and then for the sidewalk, we add an extra like width, which is W, so plus W. And then there's also that same width on the other side, so we would add the W on the other side of the 12 as well to get the total width, or length, I guess, depending on how you're looking at it. But now we just want to go ahead and get like a more simplified version of that W plus 12 plus W. We can just go ahead and combine the two W's into 2W plus 12. So I'm going to rewrite this as 2W plus 12, and that represents the width of the garden, including the sidewalk. And then for the height, we can see right here that the height is 6, but we have to incorporate the like sidewalk that she wants to add around as well. So for this entire like height, we have 6, and then we add the width right here, so plus W. We also add the width of the sidewalk right here, so plus W again, and then of course we can simplify that. We can just go ahead and combine the like two W's into a 2W, and then rewrite it that way, so that would be 2W plus 6. So just to kind of recap that, the original dimensions of the garden were 6 by 12, and then we have to add that width of the sidewalk, which is represented by W, to each side. So because we're adding it to each side, it ends up being 2W and 2W, because there's 2 of them. Okay? Okay, so now we can go ahead and set up an equation to represent the combined area of the garden and the sidewalk. So it's a rectangle. So the formula for the area of a rectangle is length times width equals 187. Nope, sorry. Length times width, I got ahead of myself. Length times width equals area is the formula for the area of a rectangle. Got a little excited. And now we have the like dimensions of this rectangle. So the length is 2W plus 12. We can put that into L, so 2W plus 12. And then the width is 2W plus 6. We can put that in for W, so 2W plus 6. And then that's equal to the total area that we're trying to get to, which is 187 square feet, so equals 187. Okay, and then now ultimately, if we want to find width, our goal is to solve for W. I know we don't have a W squared right now, but that's just more because this is kind of more in factored form, so it's not fully simplified. But once we do FOIL, we will get like W squared, which means we have a quadratic. So we have a bunch of methods for solving quadratics. So when you set up the equation, usually, I mean most of the time, your first step is going to be to get the equation in standard form. So in order to get this in standard form, the first thing I need to do is FOIL it. So I would do 2W times 2W, so do 2 times 2, which is 4, and then W times W would become W squared. And then 2W times 6 would become 12W and then 12 times 2w, so it would become 24w, and then 12 times 6, so plus 72 equals, and then just bring down the 187. And then from there, we can do a couple things. We can combine like terms. So the 12 and the 24w, we can combine those because they both have w to the first power. So 4w squared, and then when you combine like terms, you just add the coefficients. So we would add 12 and 24, so 12 plus 24 is 36. And then if we're trying to get in standard form, we want everything on one side of the equal sign. So I'm also going to just go ahead and subtract over this 187 so that I can get the entire equation equal to 0. So then I would do 72 minus 187, negative 115. And then equals the 187 minus 187, that becomes 0. So like the last thing I did, you can technically do that in like another step, but I just wanted to save us some writing. So from this step to this step, we combine like terms. The the 12w and the 24w became 36w. And then we also just subtracted over the 187 to get everything on one side of the equal sign equal to 0. Okay, so now we have our equation in standard form, so now it's time to decide what method we want to use to solve this. So when I say what method, methods of solving quadratics like factoring, square roots, completing the square, or the quadratic formula. Usually the larger and the more kind of like complicated the number, like the coefficients are, the more likely it's going to be that you use the quadratic formula. And here's a good quadratic formula example. You could absolutely try to factor it. I don't know if it's factorable, but you would probably take just as much time trying to decide if it was factorable as it would take just to solve using the quadratic formula. So we're just going to go ahead and do that. So we need to figure out what a, b, and c are. So a is the coefficient of w squared. In this case, usually it's x squared, but so a is 4, and then b is 36, and c is negative 115. And then usually when we write the quadratic formula, it's like x equals negative b, blah, 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 the rest of it. In this case, our variables are w. So we'll do w equals, and then the quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. So let's see, c is negative 115, that'll go there. Not sure why I started from the back, but I'm here. B is 36, that'll go here and here. And then a is 4, so it'll go here and here. And then from there, we can go ahead and just plug everything in. So b was 36, so negative b would become negative 36, and then plus or minus the square root of b squared, so 36 squared minus 4 times a, so times 4 times c, so times negative 115. And then all over 2a, so 2 times 4. And then we'll just work on simplifying the inside of the radical. So I'm going to bump this down to the next line. So w is equal to negative 36, and then plus or minus. So for the inside of the radical, I can do 36 squared, which is 1,296. And then we have to be really careful with the signs whenever we're simplifying the inside of the radical. So I've talked about it before, but I like to think of this like minus sign as a negative that goes with the 4. So I would do negative 4 times 4, which is negative 16. And then I would do negative 16 times a negative 115, which would turn it positive because it's a negative times a negative. So it would turn into a positive 1,840. And then all over 2 times 4 in the denominator, so all over 8. Okay, so one more time, just like really quick. If you have a way that you prefer to do it, like this is not the only way to do it by any means, but usually to keep my sign straight, I just like to think of this as minus, as a negative with the 4. So it's negative 4 times 4, which is negative 16, and then negative 16 times a negative 115 would become a positive 1,840, so this is a plus. And then we can go ahead and add the numbers inside the radical. So negative 36 plus or minus the square root of 1,296 plus 1,840 is 3,136 over 8. And then sometimes, like when you're using quadratic formula, you kind of stop and then you simplify the radical. Usually when you're like dealing with word problems, you want your answers to be like kind of in like the simplest terms possible. So what that means is like instead of like simplifying the radical and having the radical kind of still in your final answer, we'll just go ahead and get a decimal approximation for it. So for the square root of 3,136, oh, it's a perfect square. That's cool. Okay, sorry, I didn't know that. 3,136, if you square root it, it's 56. So that's nice. So this becomes negative 36, and then plus or minus 56 over 8. Okay, and then now that, wait, I'm gonna backtrack a little bit. If it wasn't a perfect square, it's okay. You could just do a decimal approximation, but my point is like for word problems, you don't really want radicals in your final answer. You want like something that if somebody were to ask you, you could just tell them a number that would make sense to them. Like if she's asking what the width of her sidewalk should be, I don't want to tell her her width in terms of radicals because that's super confusing. Okay, so now, oops, I forgot the minus when I fixed that. So negative 36 plus or minus 56 over 8. And now that like the radical part is gone, we can go ahead and separate this into like two different versions of the answer. So one that has the plus and then one that has the minus. So kind of like two different equations. So W equals negative 36 plus 56 over 8. And then W equals negative 36 minus 56 over 8. So one that has the plus, one that has the minus, and we'll just solve both separately. So if we do negative 36 plus 56, it's 20 over 8. And then negative 36 minus 56 is negative 92 over 8. And then we can just, I know it, like we usually leave it as like an improper fraction where we're just solving, but same thing kind of here with word problems, just go ahead and get the decimal. And I'll explain more in a little bit. So 20 divided by 8 is 2.5. So it'd be x equals, or not x, but w equals 2.5. And then when we were talking about dimensions, it gave us the dimensions in feet. So we would say 2.5 feet. And then for like the other width, if you recognize that that's going to be a negative, you could technically stop there because we can't have a negative width. But just keep solving it all the way through. If I do negative 92 divided by 8, be negative 11.5. So you can't have a negative like distance, and since we're trying to find the width of the sidewalk, it doesn't make sense to have a negative width. So it is like we didn't do anything wrong. It's still technically a solution. It's just called an extraneous solution. It's like one that doesn't actually make sense in the context of the problem. And this is how it is spelled in case it never comes up for you. But our like actual answer for this problem would be W equals 2.5 feet. And then just kind of going back to like with word problems, getting like kind of giving your answer in a way that would make sense to like somebody walking down the street. So I could have technically reduced like 20 over 8 to what is that, 5 halves. But if somebody was like, hey, like I really need help, how wide should I make my sidewalk? And you're like, oh, 5 halves feet. Like they're probably gonna look at you like, I don't know, like you're a jerk. But if you just tell them like, oh, make it 2.5 feet wide or 2.5 feet wide, I feel like that makes a lot more sense to the average person walking down the street. Okay, so W equals 2.5 feet. Okay, so example 2, the height of an object that is launched upward can be modeled by the formula h equals negative 16t squared plus v with a little subscript of 0t plus h with a little subscript of 0, where h is the height in feet and t is the time in seconds. Before I move on to the next little paragraph, when you see something that has like this little 0 subscript, it means initial. So not like signing your name, but initial as in like starting. So initial, this would be like initial velocity because it's v with a little 0, and then this would be initial height because it's h with a little 0. And that's like, you'll see that probably in the future at some point as well, so just kind of something that's helpful to know. And then starting with the second kind of paragraph section, Emily shoots an arrow upward with a bow from a height of 33.6 inches. The initial velocity of the arrow is 75 feet per second. Write an equation that represents the height of the arrow in seconds after it's shot, and then find the maximum height. Okay, so we have to use that formula that is highlighted in yellow to write our equation. That's not something that you would like be expected to come up with it on your own, like with the negative 16. It's just a formula that is for like all upward like trajectory items. So like a bow that's shot or like a ball that's thrown, we would always use this formula to represent it. The negative 16, like if you take a physics class, it kind of comes in with like gravity. Okay, so I'm going to go back to the second paragraph. So it says that she shoots an arrow upward with a bow from a height of 33.6 inches. So that 33.6, it's not like just h, like regular h, it's our initial height where she's shooting the bow from. So it would go in for the h with the little 0 next to it right here. And then for the initial velocity of the arrow is 75 feet per second, so that's our v with a little 0, the initial velocity. So we'll put that in right here. And then the regular h, like without the subscript, and the regular t just stay as is in the formula. So our formula or our equation would be h equals negative 16t squared. And then plus, next would be our initial velocity, this part right here, which our initial velocity is 75 feet per second, so plus 75t. And then next is our initial height, and our initial height was 33.6. I forgot to do something, so I'm going to go back and fix it really quick. Okay, so we're going to end up changing this, but it's a good starting place. Okay, so what I forgot was that, which I mean, I'm kind of happy I forgot because it's a good, like, let's learn from our mistakes. So it says that the initial height was 33 inches, 33.6 inches, but velocity is 75 feet per second. So those are in like two different units of measurement. So we need to get them into the same unit of measurement. I'm going to get them both into feet. So if I want to take that 33.6 inches and convert it to feet, I have to take 33.6 and then I'm going to divide it by 12 inches. And then that's going to convert it to feet for me, right? Because there's 12 inches in a foot. Okay, so 33.6 divided by 12 is 2.8. So 2.8 feet. And then if you go to like the workbook, there's like the fancy, I always forget how to write it, like kind of the way that you convert units in chemistry and stuff, if you want to check that out. But if you need to convert inches to feet, you can just divide the inches by 12. So that 2.8 feet has to replace my initial height in the equation that we created. Okay, so one more time really quick, just to set up. So they gave us the initial height in inches, but velocity is in feet per second, and the formula is also structured in feet per second. So you can see like where h is the height in feet, and t is the time in seconds. So we just need everything to be in feet. So since they gave us the initial height in inches, we had to take those 33.6 inches, divide them by 12 to get 2.8 before we can put it into our equation. Okay, so there is a couple different ways now that we have the equation to find the maximum height. So this is not a like quadratic formula type of problem. So it says right here, then find the maximum height of the arrow. So this is a quadratic. It has a negative a value, so that means that it's a quadratic that opens down. And that makes sense. It's like an arrow that's being shot upward, so the vertex would be the maximum height. So basically, this problem is asking us to find the vertex. So one way is, and we've talked about this way in the past, is to use completing the square to put this equation, which is in standard form, into vertex form. So remember, vertex form would be like, well, in this case, it would be h equals a times t. I'm just going to write it in x and y. I feel like that's easier. Vertex form is y equals a times x minus h squared plus k. So that's what the workbook, like the written workbook, does for 8.2. So if you want to look at that example, you are absolutely welcome to. I'm just going to show you an easier way here because that's just a really tough way to do this problem. So if you're interested in the completing the square, look at the work in the workbook 8.2. If not, I'm going to show you a different way. So there is something called, it's a vertical line that cuts through the vertex called an axis of symmetry, because quadratics are symmetric. So that vertical line that cuts through the vertex is called the axis of symmetry, and there is a formula that we can use to find that. So the formula for the axis of symmetry, usually we say it's x equals negative b over 2a, but here, like, our variables aren't x's, they're t's, so I'm just going to put a t. And what that does is that gives us the first coordinate of the vertex. So like that would be normally like my x coordinate, but we have t's and h's here, so it's a little bit different. So I'm going to use that formula, and it's going to give me the first coordinate of my vertex. So it's the same like a, b, and c as like normal standard form. So if I want to find t equals negative b over 2a, b is 75, so it'd be negative 75 over 2 times a, so 2 times negative 16. And this doesn't really show up in your workbooks. It's just like an alternative way, so it's your first time seeing it, so don't feel like you should already know this. And then we can go ahead and multiply the 2 times the negative 16, which would become negative 32. And then we can divide negative 75 by negative 32. And we get a decimal. I'm going to round it to 2 decimal places. So it's about 2.34. Okay, so that formula, negative b over 2a, gives you the like essentially the x coordinate of the vertex. So this would be a 2.34. And then if I want to find the y coordinate of the vertex, which is the max height for this problem, because that's like the height of the vertex, I just have to take that number and I have to put it back into my equation where t is. So I'm like substituting it in to find the height at that time. That 2.34 represents like how long it would take to get to its max height, and we just need to find the actual height now. So I'm going to take that 2.34 and put it into my equation where t is, so it's negative 16 times 2.34 squared plus 75 times 2.34 plus 2.8. So that 2.34, that's the time it takes to reach its max height. Now, if we just solve this, it'll give us the actual max height. So we'll do 2.34 squared. It's like 5.4756. I'm just going to go ahead and multiply it by like the negative 16 though while I have it in my calculator. So times negative 16 Altogether, it'd be negative 87.61-ish if you round to two decimal places. And then for 75 times 2.34, it's 175.5. And then plus 2.8. And then now we can add those all together. So 87 or negative 87.61 plus 175.5 plus 2.8 is 90.69. So the max height is approximately 90.69, and this was in feet. Okay, so like I said, this is one way. There is another way. The other way is written in workbook 8.2. You can decide which one works best for you. Okay, so example 3, sorry, these are each pretty long problems. We have 2 more-ish to go through. Okay, so example 3, there's 2 consecutive odd integers whose product is at least 63. So when you see the word at least, that's usually a word that represents an inequality. And it says write an inequality right here. Should just underline that. But anyways, write an inequality that represents the possible values of the first integer, then solve the inequality to identify a few pairs of integers for which this situation would be true. So, two consecutive numbers means like 2 numbers back to back. But like examples of 2 consecutive odd integers would be like 1 and 3, or like 7 and 9. So we can write, I guess, the second one in terms of the first one. So I'm just going to use x. So I can say x is the first odd. And then to get to my second odd, if you look at like these couple of pairs of like consecutive odd integers, so like say 13 and 15, like there's a difference of 2 between them. Like if I have 1, I have to add 2 to get to 3, or like 7 plus 2 is 9, or 13 plus 2 is 15. So to write my second odd, I would have to make it x plus 2, because that's the difference between any 2 odd consecutive numbers is 2. And then the problem itself, it says that their product is at least 63. So product means to multiply. So when we're setting up our equation, we would do x and then times x plus 2. That's the product of the first odd and the second odd. And then it says at least. So whose product is at least? At least means greater than or equal to. So at least like it can be equal to 63, or it's more than 63. So it's greater than or equal to 63. And then now we have an inequality that we can go ahead and solve. So kind of same thing here as before. We want to get it in standard form. So I would distribute the x. So x times x is x squared. And then x times 2 is 2x. And then it's greater than or equal to 63. I want to get it in standard form, so I'm going to subtract over the 63. And then x squared plus 2x minus 63 is greater than or equal to 0. I don't know if you'll see a problem where this happens, but just remember, like with inequalities, if you have to multiply or divide by a negative, you have to flip the sign. It's probably something you learned a while ago. Okay, so we have x squared plus 2x minus 63 is greater than or equal to 0. This is a good example of one that would be worth it to try to factor it, because the numbers are pretty simple. So the lead coefficient is 1, so we just need numbers that multiply to c but add up to b. So multiply to negative 63, add up to 2. So those two numbers would be 9 and negative 7. So when we factor it, we use those two numbers to factor it. So we would do x plus 9, since it was a positive 9, and then x minus 7, since it was a negative 7, is greater than or equal to 0. And then now it's in factored form, so I just need to set each factor equal to 0. So I would do x plus 9 is greater than or equal to 0, and then x minus 7 is greater than or equal to 0, and I solve each one separately. So I would do like minus 9 minus 9. X is greater than or equal to negative 9. And then over here, I would add 7, and then end up with x is greater than or equal to a positive 7. So keep in mind that like x represented the first odd, so like our pair isn't negative 9 and positive 7. That's just each of those is the first odd in our pair. So a couple of different like pairs that we could use so to identify a few pairs of integers for which this situation would be true. So from the like x is greater than or equal to 9, so or negative 9, excuse me, we could do like that kind of looks like subtraction. I'm going to do it off to the side, or at least in a different color. So we could do like negative 9 and negative 7, because negative 7 is greater than negative 9. Or we could do, let's see, another one that was greater than, we could do like negative 7 and negative 5. Those are both consecutive, but this is the first odd. And we just need it to be, oh no, that's not right. Sorry, I lied to you. For x is greater than or equal to negative 9. I think I'm overthinking it. But anyways, I'm going to jump over to the x equals, or x is greater than or equal to 7. I might have to clarify that in the live session. I just don't want to waste time on the video doing it. Okay, so the other pairs we could use are like 7 and 9. If we multiply those two together, be greater than 63. The next pair would be like 9 and 11. If we multiply those two together, it would be greater than 63, and so on. Okay, moving down to 8.3. So interpreting quadratic equation features in context. So we have obviously a graph of a quadratic. So the equation that represents Emily shooting the arrow is h equals negative 16t squared plus 75t plus 2.8. That's the equation that we found in example 2 from 8.1, 8.2. And here it is graphed. So we just want to take a look at the domain, the range, the vertex, and the y-intercept, and interpret what they mean in the context of this problem. Okay, so domain. So typically for domain for quadratics, it's all real numbers, like any possible x values, but that's just when you're given like a general equation. And in this case, like we have a real life scenario, so the domain is limited. It cannot be, because like domain is our input values, and in this case, input is time. There can't just be unlimited time. There can't be negative time and then unlimited on the other side. So to figure out our domain here, we have to actually like look at the graph, look at where it starts and look at where it ends. So it starts at like t equals 0, and then it ends at t equals 4.72. So the domain, we would write in interval notation, and we would use a bracket here because it can include 0, like there can be a time of 0 seconds. And then it ends at 4.72, and there's an exact point there, so we'd use a bracket around that. So what that means in the context of the problem is that is the amount of time that the arrow is in the air for. So we can say like how long the arrow is in the air. And then for range is like the, in this case, well, in all cases, it's the output, but in this case, the output is the height. So it's like, what is the range of our height? So the height starts right here at 2.8. This is the y coordinate now. And the highest point that it goes to is 90.7. I think that was a little bit different than we did in example 2, but it's like more of a rounding thing than anything else. I think we maybe put 90.69. So, okay. Anyways, that's the maximum height though. And so our range, the lowest possible value of the height is 2.8. And then the max height, like the highest value it goes up to, is 90.7. And then for like brackets versus parentheses, the height can include 2.8. That's where it starts at, so we put a bracket around it. And it can include the max height 90.7, so we put a bracket around that. And then the vertex, we can see it right here, is this point 2.34 and 90.7. And the vertex is just, that's the highest point that the arrow reaches. And then I forgot to add like the written context for the range, but for written context, it's just I guess like the span of the heights of the arrows. It may have a better way to say it, I'm not sure. But we could say the span of the height. And then for y-intercept, you can see that's where it crosses or where it hits the y-axis. So you can see it's at 0, 2.8. That's the starting point. And that's always the case, is like our y-intercept is where we're starting. So the y-intercept is 2.8, and that's the starting point. Because she shoots it from a height of 2.8 feet in the air. And then for the x-intercepts, so we don't have one like over here on the left side, because it's not going to cross. That would be like crossing over on the negative side of the x-axis, so that would be like extraneous. And then over here, this is an x-intercept at 4.72. And that's just where the arrow hits the ground, because like the y values, like the y-axis, that's the height. So for it to be an x-intercept, it has a height of 0, and that's where the arrow hits the ground after it's flown through the air. So the x-intercept is 4.72. And remember that the x's is in like time, so that's just how long it takes for it to hit the ground. So x-intercept 4.72, how long it takes for the arrow to hit the ground. That's in seconds if you want to add it, but here's all of our interpretations. I just want to pop on here really quick and just clarify last thing for example 3 from the 8182 section in case anybody misses the live. So I wrote before like my second option, I guess, for like a pair as -7 and -5. Those are consecutive with like the first odd being -7 and then the next one being like one odd up at -5. But if I multiply those two together, it's 35. So that's not greater than or equal to 63. So because like negative numbers kind of go in the reverse order, actually for this one to work, we would have to do x is, I'm gonna write it off to the side, sorry. In order for this to work, we wouldn't use x is greater than or equal to -9. We would actually have to use x is less than or equal to -9 in order to get numbers that multiply to be greater than or equal to 63. So like if x is less than -9, we could use -9 as our first odd and then -7 as our second, but the next like kind of option or pair that we could use from that would have to be -11, like less, because that's less than -9, and -9 would be like the next option is one odd up from there. So kind of tricky. It's one of those things that you just kind of have to like guess and check, not guess and check, but pick out a few pairs and see what works. Fortunately for this problem though, it wasn't like we just had to identify a few pairs that worked, and we did that.